Hey guys, welcome to this session by Intellipaat. And in this session, we're going to look into Docker interview questions. Docker is one of the most integral parts of the DevOps ecosystem. And Docker is used for containers. And in this session, we'll be looking into the Docker interview questions from the very basic to the most advanced levels. And before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Now let's begin with this session. Hey everyone, welcome to this session by Intellipaat. So now let's get on with the interview question session. So right now we'll look into the basic questions, and then moving ahead we'll look into intermediate and also advanced questions. So again, this is an interview question session. So basically I'll be telling you the question and then I'll be giving you an answer. Will not be going beyond or like understanding what is Docker and all that. We'll be concentrating only on the interview questions. If you want to learn more about Docker, please go check out our Docker tutorial in our YouTube channel, where we have detailed answers for every question you have, and also hands-ons and projects over there. So now let's start off with the first question, which is obviously what is Docker. So now we can define Docker as a containerization platform that combines all our applications in a package so that we have all the dependencies to run our applications in any environment. So basically it is a containerization platform. So let's say your applications require certain dependencies, certain packages. So now the Docker container puts them all together in one single location so that you can basically run that container anywhere on any app, any environment, on a cloud system, on your local PC, on your on-premise setup. So anywhere you can run that container, because that container has all the dependencies and all the packages to run the application within it. Now, this means that application will run seamlessly on any environment, and this makes it easy for having a product ready application. So let's say you want to run it on a Mac operating system, Windows, Linux, all at the same time. You can go ahead with a containerized application. So that would be much easier for you to deploy. Okay, so this is the basic of Docker. Now let's just compare Docker and virtual machines to get a better idea. So now virtual machines, again, you can create virtual machines to run certain applications on your PC, right? But Docker containers basically share the host operating system. That means if you're having a Windows operating system and if you're running multiple Docker containers over the Windows operating system, those Docker containers will not have separate operating systems. They'll basically share the same operating system as the PC. But virtual machines, you'll have to install its own operating system. Only then you can move ahead with whatever task you want to do on it. Startup time is very fast for Docker because they share the same OS as the host. But virtual machines has to be booted. The bootloader has to run. Once the bootloader has to run, you have to log in and then only it opens. Obviously, it is slower than Docker. For an app, if you're going to host an application, in that case, Docker is the better option than a virtual machine. Isolation, process level isolation, full isolation. So Docker, as it shares the operating system, it does not have complete isolation to the system which is hosted on. So it has process level isolation. Whichever process which is running inside the Docker container is isolated from the operating system which it is hosted on. But the virtual machine is fully isolated because it has its own operating system. Security is low on Docker. The only way of getting it higher security is that you host it on a server which is really secure and your code is really secure. Virtual machines has high security because again, it is a virtual machine, has its separate OS. You will have to log in into it, only then you can move ahead. Okay, so this is what is Docker. To be very simple, it is a container, or it is basically a folder. It's not a folder, but let's just consider it like this. It's a folder with all the things you require to run an application. So now if that folder can be basically used on any environment, it can be used on a cloud or your own PC. So it can be run everywhere. And these are the attributes. It shares the operating system. It's really fast. It has process level isolation, and the security is low. You will have to make it even more secure in your code. Coming to the second question, what is the benefit of using a Docker over a hypervisor? So now, what is a hypervisor? Let me tell you that. So hypervisor is the software which is running on servers in a cloud system or an on-premise system. So these hypervisors basically create virtual machines for you. So now here we saw about virtual machines, right? So hypervisors are the software running on physical servers. Basically they create the virtual machines which you demand for. So let's say you're using AWS or Azure and you're basically creating a virtual machine. So when you provide all the details and configurations and click on create, this particular detail is sent to the hypervisor in the physical data center, in whichever data center you're choosing it to. So that hypervisor gets it and creates the virtual machine which you're asking for and gives the details back. That is the IP addresses and all that. So now that is what an hypervisor is. There is still more to learn about hypervisors, but that's not the case here. Just I gave you a brief example. So now, though Docker and hypervisor might do the same job overall, there are many differences between them in terms of how they work. So Docker can be thought of as a lightweight since it uses very fewer resources and also the host kernel rather than creating like a hypervisor. So the main difference here is Docker does not create its own virtual machine which has its own operating system, which has its own attributes and environment variables. No, Docker is a smaller part of the operating system which it is running on top of. So that's why it is called lightweight. So when it is lightweight, it is much easier to deploy a Docker container than a virtual machine, and to run your application on Docker is much easier. So if you're going to create an application, if you want the application to load faster, if you want the application to run on any environment you want to put in, you'll have to go with Docker rather than a hypervisor, which basically creates you virtual machines. Third question, what are the unique features of Docker over other containerization technologies? Some of the most important and unique features of Docker are as follows. We can run our Docker container either on our PC or on our enterprise ID system. So now you can basically run Docker on your own personal computer or on the enterprise IT system, that is your own data center's server, or you can also run it on a cloud-based server. So these are the options for you. Second, along with the Docker Hub, which is a repository of all the containers you have, we can deploy and download all our applications from a central location. That is, let's say you have multiple Docker containers and you want to check out all the applications which you have created on these Docker containers in one single location. You can basically check the Docker Hub and download all of that from that central location. This is the second point or the second feature why Docker is really popular in the DevOps or the cloud community. Then finally, we can even share our applications with the containers that we create. So basically, if you have one container with an application, you can basically share the same application across multiple containers. So if you want to share it to another person who's going to create their own containers, you can still do that. You can still share your applications to others who can basically create their own container and host this application on top of it. So these are three of the most important and unique features why Docker is popular. First, you can run it anywhere, PC, data center, cloud, doesn't matter. Second, you have Docker Hub, which is basically a central location, which basically acts like a repository from where you can download all the applications. Third, you can share those applications across other containers. Coming to the fourth question, which is what is a Docker image? So a Docker image helps in creating Docker containers. So now get this. So Docker image is the one which is used to create Docker containers. So Docker containers are the physical entity, and Docker image, from the name itself, it is a blueprint or a template which is used to create these Docker containers. So we can create the Docker image with the build command. Due to this, it creates a container that starts when it begins to run. All the Docker images are stored in the Docker registry, such as the public Docker registry. So whatever Docker image you create gets stored in the Docker registry, and you can basically check it out whenever you want. So these have minimal amounts of layers within the image so that there is a minimum amount of data on the network. Okay guys, if you're looking for an end-to-end training in Docker, Intellipaat provides a complete certification training in Docker, and those details are available in the description box. Now let's continue this session. So now coming back to the second point. So when the Docker image starts to run, it creates the Docker container. And the third point is that the minimal amount of layers. That means as lesser the layers are, as lesser the data would be. So that makes the Docker container really small and tight, so that the data is less and it's really quick to start up So that's the reason why people prefer Docker containers, because they are quick enough to launch. Okay, so this is the fourth question. Coming to the fifth one. Now, what is a Docker container? So we've saw Docker image. So now coming to Docker container. It is a comprehensive set of applications, including all its dependencies with which basically share the same OS kernel as the host. So along with the other containers running in separate processes within the operating system in the user space. So now in the same PC, there can be multiple Docker containers running. So all the Docker containers share the same operating system. But even though they share the same operating system, each Docker containers are isolated from each other. So even though the host operating system and the Docker container have a little bit of communication between them, there is not full isolation, but the Docker containers which are available, let's say there are 3 Docker containers, so all of the three Docker containers are completely isolated from each other. They will not have any connection unless you try to communicate with each other. So now basically the Docker container is a set of applications or a single application with all the dependencies which are required to run that application. So that's it. Docker container is basically a folder with all the applications and all the dependencies which are required to run that application, which basically runs on a shared operating system. Then Docker is not tied to any IT infrastructure. So basically it is there is no dependency for Docker to run on anything. It is not tied to an IT infrastructure. So that basically means it can run on any computer system or on the cloud without any problems. And we can create a Docker container using the Docker images which are already available, or a Docker image which you create and then run it, or you can use the images which are already created in the Docker Hub. So the thing is, you create Docker images and you can basically use them whenever you want to use, because as I told you, they are basically templates which you can use again and again. So when you use the same Docker image, they'll create Docker container with the same set of applications with the same set of dependencies as you require. So that's how it works. And as it is not tied to any IT infrastructure, you can run it on AWS, Azure, GCP, your own personal computer, doesn't matter. To simplify things, let us say that Docker containers are just runtime instances of the Docker image. So basically Docker image is the copy, and when you create a Docker container from the Docker image, basically that Docker container is right now running with all the details provided by the Docker image. That's it. Okay, so these are the basic questions. We completed them. Now moving on to the intermediate interview questions. Coming to Docker Hub. So what's a Docker Hub? We can think of Docker Hub as a cloud registry that lets us link the code repositories, create the images and test them. Basically, it's a central repository or a central cloud repository. So it has all the, basically you can link the code repositories. You can also create the Docker images over here, and you can test the Docker images directly from the Docker Hub itself. We can also store pushed images. So basically you can push an image from another place, or you can basically link it to the Docker cloud so that the images can be deployed to the host. That is, you can connect Docker Hub to an AWS hosted Docker container, and in this case you can basically push this Docker image into the ECS or the AWS registry, and from there you can basically run it on the AWS's container. So you can basically push images directly from the Docker Hub. And we have a centralized container image discovery resource that can be used for collaboration of our teams, automating the workflow and distribution, and changing management by creating the development pipeline. So as I told you, it is the centralized container image discovery resource, or the centralized repository for Docker, which can be used for collaborating within your team. And also you can basically automate the workflow and distribution. That is, if a person creates a Docker image, they don't need to send it to every single person in the team. They can upload it to the Docker Hub and it can be retrieved from there. That basically is distribution and automating the workflow, and also changing the management by creating the development pipeline. You can basically develop the pipeline accordingly, that whenever you push certain images, they automatically start running and create the containers for them. So this is basically what a Docker Hub is. The next question is, what is Docker Swarm? So to be very simple, we can think of Docker Swarm as the way of orchestrating multiple Docker containers. We will be able to implement Dockers in a cluster. We can convert our Docker pools into a single Docker Swarm for easy management and monitoring. So the very basic is over here is basically you have multiple Docker containers because one Docker container will not do anything for you. So you'll have multiple Docker containers, and when you have multiple Docker containers, you need to basically manage them, right? So to make it easier for you to manage, you can create them in a cluster as a single Docker Swarm. And when you create a single Docker Swarm, it'll be really easy for you to manage and monitor them and troubleshoot them whenever there is an issue. So this is what a Docker Swarm is. Now, what is the use of a Docker file? A Docker file is a set of specific instructions that we need to pass on to Docker so that the images can be built. So now you run the Docker file to create the Docker image, and then you run the Docker image to create the Docker container. We can think of a Docker file as a text document which has all the commands that are needed for creating a Docker image. So as I told you, it's a file, it's a text document with all the details, all the variables required to create a Docker image. And we can create an automated build that lets us execute multiple command lines one after the other. So basically we create a Docker file with all the required commands one by one in the same file, which basically creates an automated build. You can basically create a Docker image in a single go. The ninth question, is it possible to use JSON instead of YAML for Docker Compose? So we'll see what is a Docker Compose later. So now we can use JSON instead of YAML for a Docker Compose file. When we are using the JSON file for composing, we have to specify the file name with the following command, that is docker compose -f for file. You're basically mentioning the file. That is what the -f flag is for. So docker compose.json, you'll have to mention up. This is the command structure when you're going to use a JSON file for a Docker Compose file instead of a YAML file. Tell us how you have used Docker in your past position. So this is basically a generic question. So now this is a question wherein you would bring up your own experience with Docker and any other containerization tools. And we could also explain the ease that this technology has brought in the automation of the development to production lifecycle management. So the first two things is you'll have to basically discuss how you use Docker, where you use Docker, and how it made it easy for you in your previous job. Or if you have not used Docker, not a problem. You would have used any other containerization tools. If you have used any, you can mention it and talk about that. Also, we can discuss other integrations that we might have worked along. So for example, if you're using Docker, you might also have used other DevOps tools like Puppet, Chef, Jenkins, Nagios, Kubernetes. So you would have used these tools. So you can mention them. That would add more value while you're talking about Docker. And if you do not have any experience with Docker, you can basically talk about the similar tools in that same area. Let's say you're not used Docker, but you've used Kubernetes. So in this case, you can just talk about Kubernetes, and you can say you can easily adapt with Docker because you know the idea of it. You have seen how it works, and you know how Kubernetes works. So you can basically learn how Docker works easily. And we could convey the same and also show our interest in learning this leading containerization technology. So if you have learned it, if you have used it in your previous company, talk about it more. If you haven't used it, talk about the other tools you have worked with, and talk about how you're going to basically learn Docker before joining, or learn Docker in the training period itself, so that it would be better for you when you get into the company. Okay. The 11th question. So what is the process for creating a Docker container? So first, we can use any Docker image for creating a Docker container using the below command. So you already have created a Docker image right now. So Docker image is ready. So now you want to create a Docker container. So to create a Docker container, you'll have to run this command, docker run -t-i command and name. So basically the command not only creates the container, but it basically also starts it for you. So the name, in the place of name, you'll have to provide the Docker image's name. So if you want to check whether the Docker container has been created or not, then you'll have to run the following command, which is shown below, docker ps-a. These are the two commands you'll have to remember to run or create a Docker command. To create a Docker container from a Docker image, docker run -t-i command and the name of the Docker image, and it will create it for you. Now, what is the process for stopping and restarting a Docker container? For stopping a Docker container, so once you create a container, once you basically run the Docker image, while the Docker container is created, you will get a container ID for that particular container which got created. So now to stop that container, you'll have to use the container ID. Okay guys, if you're looking for an end-to-end training in Docker, Intellipaat provides a complete certification training in Docker, and those details are available in the description box. Now let's continue this session. So Docker stop container ID, and if you want to restart it, Docker restart container ID. That's it. 13th question. How do you scale Docker containers? So to be simple, the Docker containers can be scaled to any level. It can have hundreds or thousands or even millions of containers running at the same time. So the only thing which has to assist you to do this is the cloud infrastructure or your own data center. So the data center or the cloud system which you're having should basically have enough compute capability and storage capability to run thousands of Docker containers at the same time. In that case, it's very easy to scale up. So the only condition is that containers obviously need memory and the operating system all the time. So in that case, the servers which are running, so basically the servers which are running, and on those servers the Docker containers will be running. So all the servers should be running all the time. So the number of servers will be increasing whenever the number of Docker containers has to be scaled up. And there should not be a constraint on these when the Docker is getting scaled. That is, the servers should not be restricted to be created more. If you're restricting that, in that case, more Docker containers will not get created. So how do you scale? It's pretty simple. Let's say you have a server on which 10 Docker containers are running. Let's say that particular server can handle only 10 Docker containers. In that case, if you want to add 20 more Docker containers, you'll have to create 2 more servers and run 10 each in those both servers. That's it. So it just keeps increasing like this. And when you want to reduce the number of Docker containers, you can basically use the same process. In this case, you'll just decrease the number of servers. That's it. Okay, now moving on to the advanced interview questions. The first question, which is also the 14th question. So where can the Docker Compose be used? So now the 14th question, where can we use Docker Compose? So Docker Compose is a tool that lets you define multiple containers and their configurations via YAML or a JSON file. So using Docker Compose, you can basically create multiple containers in a single go by just using a single document file. It can be YAML or JSON. So the most common use for a Docker Compose is when your application has multiple dependencies. So it can be MySQL or Redis. It can be any other dependencies, doesn't matter. If there are multiple dependencies, then using Docker Compose is the best option. Normally during development, these dependencies are installed locally onto the servers which they are running these Docker containers. So a step that then needs redoing when moving to a production setup. But you'll have to redo them in the production setup only if you're not using Docker Compose. So you can basically avoid this by using Docker Compose. So once you set up, you can bring all of the containers and dependencies up and running with a single Docker Compose up command instead of doing it individually for every single Docker container. So that's the purpose of Docker Compose. You don't have to redo the exact same things which you did on your local setup in the production setup. You can simply use the Docker Compose command to bring them all up running with just one single Docker Compose command. Coming to the 15th question, why Docker monitoring is significant? So monitoring helps you identify issues proactively. That basically helps prevent the system outages which can be caused. So when you keep monitoring Docker, and you can basically set up certain threshold, and if they cross it, you'll basically be alerted via mail. And once you get that, it basically shows you that the Docker containers are not performing well, and you can troubleshoot them. When you monitor time series data, basically in a period, in basically time period. So when you're looking into, let's say, the last hour or the current real-time data, so they basically provide you insights on how to tune your applications for better performance. So they show you at which time the application has been used to its maximum extent, and if it is not being used to its complete performance, in that case your application is not fulfilling your needs. So you'll have to basically fine-tune your applications for better performance. And when you have full monitoring in all the servers which the Docker containers are running in, the changes could be rolled out safely as issues will be caught early on, and be resolved quickly before it turns out as a huge problem or a root cause for the outage of the Docker containers. And the changes are inherent in container-based environments, and impact of that too gets monitored indirectly. So that is, whenever there's a change in the container-based environments, that will also get noted. Also, the impact of that also will get monitored. So to be pretty simple, Docker monitoring basically gives you an idea, an insight of what is going on in the containers and what can be tuned and what can be prevented. And yeah, so that's why Docker monitoring is significant. Now, what is the role of a .docker ignore file? So basically, to understand this particular file, the usage of this file, let's take an example. So let's say you have a Docker file in your home directory. That is, let's say you have a Linux system, and in the home directory you have a Docker file, which is basically going to run to create a Docker image. So now this Docker file is in your home directory and it launches a Docker build, and while it is happening, you will see a message uploading context. So now this means the Docker creates a .tar. So if you're running Linux, so obviously it will create a tar. It can also create a zip if you do it manually, but when it happens via the Docker file, it creates a tar. And when it creates a tar with all the files in your home directory and all the subdirectories, it basically uploads this tar to the Docker daemon. And if you have some huge files in the home directory, it will take a long time. So if you are running, let's say you have a Docker file in your home directory and you are running a Docker image, and once that runs successfully, it creates a .tar file. And when it creates a .tar file, it basically includes all the subdirectories, all the files within that particular directory. So when this happens, it will include all the unnecessary files and large files, and it will obviously take a lot of time to upload it to the Docker hub. So to avoid this, you should basically include a .docker ignore file. So what the Docker ignore file will have is, it will basically contain all the files you don't need to tar. That is, in the Docker ignore file, you will mention all the files which is not required to be tarred together. So basically, it tells you which are the files should be ignored. It tells the Docker daemon or the Docker process which is going to run that these files are not required at all. We only need these files. That's it. So that is why you need a Docker ignore file. If there is no Docker ignore file, it will basically include all the files and all the major files, and it will take a lot of time to upload. Now, what is a memory swap flag? So the memory swap is a modifier flag that only has meaning if -- memory is also set. So that basically means if only the memory is set, you can use the memory swap modifier flag. So using swap allows the container to write excess memory requirements to disk when the container has exhausted all the RAM that is available to it. So let's say the container has 1 GB of RAM, and you can use the memory swap command. And what exactly happens is the memory swap command basically helps the container to get a little bit of extra memory or excess memory, and it can basically write it to the disk when the complete 1 GB is already fulfilled by the container. For that excess bit of RAM, you need the memory swap modifier flag. So there is a performance penalty for applications that swap memory to disk often. If the container is basically swapping memory every single time, whenever something is running, every single time if it is trying to swap memory from the disk, there is also a performance penalty. That basically means the container's performance will go down a little bit. Now, the 18th question. So how to view the status of a Docker container? So now, created, running, paused, restarting, exited, and dead. These are the 6 different states for any Docker container to be in. So if you use the following command, docker ps, you can check the state in which that particular Docker container is. And the above command basically lists only running containers, but to look at all the containers which are basically, let's say it is dead or exited, restarting, paused, whatever it is, you can use the command docker ps-a, and it will show you all of that. Coming to the 19th question. What is the preferred way of removing containers? So docker remove -f or docker stop. So once you use any one of this command, and then you use docker remove command. So now the preferred way of removing containers from Docker is to use the docker stop command instead of docker remove -f. So now It basically allows sending a SIG-HUP signal to its recipients, giving them the time that is required to perform all the finalization and cleanup tasks. That is, before removing the containers, if you use the docker stop command, it gives out a signal which basically tells the container to finish off the tasks which are currently running, close off the processes which are currently running, and finish all the cleanup tasks. Once that is done, you can remove the Docker container without any issue using the docker remove command, and thereby it updates that in the Docker registry as well. And we have arrived at the final question, which is what are the different types of mounts available in Docker? So now there are three different mounts: bind mounts, volume mount, and TMPFS mount. First, bind mounts. These can be stored anywhere on the host system. There is no problem, you can store it anywhere on the host server or the personal computer. Second is volume mount. So these are managed by Docker themselves and are stored in a part of the host file system. So this part is basically mentioned by Docker itself, and it is only stored in one single part of the host's file system. Bind mounts can be stored anywhere. You can basically mount it from anywhere. Volume mount can be mounted only from a particular location. And TMFS mount, so they are stored in the host system's memory. So these mounts can never be written to the host's file system. So these are not stored in the disk. These are stored in the memory. So these are not stored in the storage itself. This is let's say it's like a cache storage which gets stored in the memory. So they are written to the memory. You cannot write it in the host's file system at any time and anywhere. So there are three mounts. Bind mounts can be written anywhere. Bind mounts can be stored anywhere. Volume mount can be stored on the host file system, but only in a specific location. TMPFS mount can be stored in the host's memory. It cannot be stored in the file system at all. It's like a cache memory. So these are the three different mounts which are available for Docker. So we've seen this, guys. So this would be the end of this session. I hope you got a lot of idea and a lot of answers from this particular session.
Okay guys, if you're looking for an end-to-end training in Docker, Intellipaat provides a complete certification training in Docker, and those details are available in the description box. Okay guys, that's it for this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below. Or if you have any new suggestions for us to make as a video, please leave that also in the comment section down below. So thank you, meet you in another session.